Welcome back. Before I actually work out, few structures, I drew two structures, okay? I want you to listen to me very carefully and then pause the video. See if you can figure out which of these two structures, while it contains correct number of carbons and hydrogens, is an incorrect structure. Quick pop quiz. Go ahead and pause the video and write down the structures if you have to on your notebook or just from the screen. Determine which of these two structures are incorrect. If they're both incorrect, or is one incorrect, or they're both correct, what is it going to be? Go ahead and pause the video. All right, assuming you have paused the video, I can tell you this is correct, this is incorrect. Why is that? Well, first you've got to identify the long chain irrespective of whatever structures you draw, okay? The longest always is going to be the straight chain. Again, straight doesn't mean it always has to be in straight line. Sometimes it can also be L-shaped, but in this I purposefully created this. So this is my longest chain, right? It contains 5 carbons. That means this is hanging off of that chain, okay? And the double bond is part of the longest chain. Whatever be the longest for the structure you draw, the double bond must be encompassed inside that, right? What's the problem here? Well, clearly my longest chain is 6, and the double bond is hanging off of the chain. Well, I said double bond cannot be outside the chain, okay, nor it can be at the end. It has to be part of the chain, okay? It has to be between 2 carbons, not outside of a carbon. With that said, this is one of the structures where I started with 4 and then added the 2. I mean, there's a host of choices, all right? I'm just not going to do everything, but I will draw 2 or 3 more structures just to prove my point. All right, so let me use this space here. So in this case, I might start with this way. Okay, again, you do not have to draw 20 structures to convince yourself that you understood the concept, okay? Here's 6, okay? So we can only have 1 double bond, okay, for an alkene. If it's an alkene, we can only have 1. We can have multiple double bonds, but we're not even there yet, okay? We have to first learn carbon and hydrogen before we can put one more element, which is oxygen, and then we start adding elements one by one, and that's how you build your chemistry knowledge, right? So we can only have 1, so I can put it here and then start putting the remaining bonds, okay? Make sure a carbon has 4 bonds. It cannot have 5, it cannot have 3, it cannot have 2. This carbon has 3, so it can have 1 more. This has right now just 2, so it can have 2. You can fill it with hydrogens, I'm sure. Now, with that in mind, I am going to actually, now don't worry about these 2 examples that I had earlier. I'm just think of it like I'm starting from scratch, okay? So that's again 6. I've just moved the double bond 1 more spot to here. This is different from this. Now you can start filling it with hydrogens, which is just, this can have 3, this can have 2, can have 2. This has 3, so it can only have 1. Again, this has 3, so it can only have 1. This is 1, so it can have 3. Okay. What if I put it here? Would it be any different than the first 2? You bet. I'm still with the long chain. That's 6, isn't it? Okay. Now that's 5. I can put my double bond here now. I moved it 1 more spot and then start filling the rest with hydrogens. You see, if I move it 1 more, that is same as this. If I'm moving 1 more to the left, it will be same as this. And if I move it 1 more further, that'll be same as this. So those are not different. These 3 are different. So 1, 2, and 3. See if you can come up with more. You can keep going, but again, on the test, you'll be given options and you have to determine if that is a possibility or not. That's much easier than me having you write a descriptive answer where I ask you to write 30 structures. Because there's 30 possible, you cannot sit and draw 30 structures on an exam or for an homework or for a quiz. It's just not practical, okay? That's unreasonable and it's not practical. But I want you to practice a couple more structures for this. I've given you a startup, okay? This is the same as this. You know, if you think about it, this right here, folks, is same as this. These two are identical, except this looks like an L, but it's same as this, okay? No, it might be, it's not same. This is only 5 carbons, this is 6, so sorry. I take my word back. This is not same as this, but I've given you one more, so it's 4. I have given you 4. See if you can come up with a couple more. It's not bad, but give it a shot. All right, I'll come back with another video for alkynes. We've looked at one of the unsaturated hydrocarbon family, which is alkenes. We're going to look at alkynes. And then we're going to do something else besides boiling point. All right, so stay tuned.